Hello, Naji.
Hi Hannah, what are you going to do today?
Hmm, I think I will explore atomic theories using my Sentra time machine.
Oh, sounds great Hannah. May I join you?
Yes, of course. We're ready for an exciting yet educational journey. Come on.
Whoopsies, I think we landed in Greece. Look Hannah, it's ancient Greece. Who do you think we will meet here?
It's Democritus, an ancient Greek philosopher who spent a lot of time wondering about the natural world.
I believe his idea of atom has been called the best guess in antiquity. Although it's correct, yet it was based on pure speculation.
What if I cut this cheese into smaller and smaller pieces until I reach to the point in which I cannot cut it anymore? I will call it atomos, the uncuttable. All matter consists of atom which cannot be further subdivided into smaller particles. Atomos are too small to see.
Oh, Naji, we are now around 1800. Let's see who will be the next to Democritus.
That teacher's face looks familiar. Let me think. Aha! He is John Dalton. He grew up in working class family. If I'm not mistaken, John Dalton made his living out of teaching and research.
Democritus guessed is correct. With my research, I demonstrated that atoms actually exist. They cannot be divided into smaller particles, created, or destroyed. The atom of this element is the same with that element. It means they have the same mass. If I join these two atoms together, we can form compounds.
Brilliant guy! Many of the scientists accepted his works. However, atoms are not the smallest particles of matter. We have protons, neutrons, and electrons.
I remember our chemistry teacher told us that J.J. Thomson comes after John Dalton. Am I right, Hannah?
Yes, exactly. He was one who discovered that there are smaller particles within the atom, opposing the claim of John Dalton.
I will begin my experiment by using this sealed glass tubes. Then a high voltage will be applied across two electrodes at one end of the tube, causing a beam of particle will flow from cathode to anode. Atom is made up of thousands of electron embedded to positively charged sphere. The magnitudes of the negative and positive charges are the same. As a result, the atom is electrically neutral as a whole.
The discovery of electrons led to Thomson's proposal, which was compared to a popular English desert plum pudding model. After the discovery of electron, what will be the next?
Any idea, Hannah? I seriously don't know.
We are now in the year 1899, Hannah. We are going to witness how Ernest Rutherford discovered the nucleus of the atom.
My curiosity sparks. I'm going to study the atom using alpha particles. I have here a thin gold foil surrounded by screen that will glow if alpha particles struck it. I will direct the beam of alpha particles onto the gold foil. Given the Rutherford's plum pudding model, will the alpha particles pass through the gold foil or will it deflect?
Yes, it will pass through the gold foil like passing through the empty space. That means Thomson's plum pudding model was incorrect. Positive charge is not spread evenly throughout the atom. Instead, it was concentrated in the tiny nucleus.
We are close to the end of this journey.
Yep, and now we are going to visit and learn the Bohr's atomic theory. This model was actually a combination of Rutherford's atomic model and Max Planck's idea of quantum. Look at Neil Bohr's.
I will combine Planck's idea of energy quanta to Rutherford's atomic model of electrons orbiting the nucleus. With this I can arrive to the idea that electrons move around the nucleus only at fixed distances from the nucleus based on the amount of energy they have. The fixed distances where electrons may orbit are called energy levels.
The biggest limitation of Bohr's model was that it failed to make correct prediction of large-sized atoms and explain the spectrum of atoms having only two electrons, such as the helium atom.
Finally, here is our last step before we go back to our time.
Yes, Naji, it's the quantum wave model by Erwin Schrödinger. His study was based on studies of de Broglie, Bohr, and Sommerfeld.
Using the previous study of Bohr, de Broglie, and Sommerfeld, I can conclude that the movement of electrons in the atom is constant, and they do not have a fixed defined position within the atom. I cannot predict the location of electron, nor describe the path it takes within the atom.
So here's the summary.